Hello there! SwiftUI was presented in 2019 during the Worldwide Developer Conference. It was an amazing innovation that fired the imagination of many developers. This technology had many flaws at the beginning, but the most pointed out was the limit of views in one closure. The 10-view limit was a big disadvantage. The reason was the implementation of finite amount of view builder's buildBlock methods. In the previous episode, we created our custom view builder, whose task is to build the target type for the view. The buildBlock method can compose an empty view type. It can compose some view type or a TupleView type, which is how SwiftUI builds a view hierarchy consisting of the multiple views. But before we get to the feature that appeared in the Swift 5.9, let's see what the TupleView type is. It is a very simple structure with only one parameter and a generic type t. It looks innocent, right? A tuple is a specific type in Swift. It is a way to group multiple values into a single unit. It lets you store different types of values together without creating a custom structure or class. Tuples are great for temporary grouping data, which is what SwiftUI uses to create a view groups. The generic type in TupleView is representing the tuple that will be a group of the views. But before it will be aliased, it should be declared. Previously, SwiftUI declared as many as 10 different variations of buildBlock method to correctly declare tuples. This was due to the lack of the better solution, which led to developers creating additional implementations. It was a popular joke. SwiftUI can't handle more than 10 views? Swift 5.9, however, solved this problem by implementing the parameter pack. This feature allows functions, types, and generics to accept a variable number of the parameters while preserving type safety. Parameter pack improved generic programming by handling multiple types dynamically. However, this is not a simple feature, so let's analyze how it works using an example. We will create a TupleType, which, like a TupleView, will have a generic type t and a value parameter of this type t. Now we will add an initializer whose only parameter will be value of type t. Let's create some sample variables based on the TupleType type. It behaves as we expected. It stores a TupleType with initialized value that have their own types. To create a tuple, we need to put our variables into the brackets. If we delete them, then our TupleType will not be initialized correctly and we'll get the error about extra arguments. This is of course true because the TupleType initializer expects only one argument. So how do you make a lot of them? Step by step. Let's first create a simple method with a generic type that will return our TupleType. Of course, this implementation hasn't changed anything and the function still takes one parameter. Now, let's break this down step by step to understand parameter packs in Swift functions. Firstly, we define a collection of types by adding each keyword to the t generic type. Now, it is a pack of types instead of a single generic type. Next, we expand the type pack by adding repeat each keyword so the values can accept multiple parameters, each with different type. Now, we have to declare a return type. The function returns TupleType containing a tuple, so we mark that all the individual types from each t pack are injected inside the tuple. Last but not least, in the function body we are repeating each values to expand values inside the tuple. Wow, great! We've actually done most of the work to create a TupleNode that works just like a TupleView in the SwiftUI. TupleNode, of course, also has to inherit from the node protocol, which adds additional complexity to the code. The body of a TupleNode, like a TupleView, does not have any body content. The type alias is never, and the type itself does not support a body. We need to implement the description parameter that is required by the protocol. It should return all the descriptions from the nodes hidden in the tuple. How to do that? Tuple does not have a method that allows iterating over its properties. Tuple can store values of the different types, making it impossible to use a single loop variable of a fixed type. They do not conform to the sequence or collection protocol, and, of course, they have a fixed size. They are not dynamic. We can iterate over the properties, we have to use a reflection by implementing mirror, which is a representation of substructure of the any type. By creating a reflection of our tuple value, we can look at its children, which, as we know, are supposed to inherit from the node protocol. This is the very important information because it is this protocol that defines the entry structure of our HTML tree. The nodes property will return us all children from the tuple that type is any node, and we know that the node protocol gives us the description parameter. We can use this inside the compute property description to return a joint array of the descriptions. Now the tuple node is ready. Let's summarize. When creating a reflection of our tuple node, we read all children that are inheriting from the node protocol to read all the descriptions and combine them together into a TupleView description. Now the tuple node is ready. We can use it in our node builder as a third buildBlock return type. We've come to the point where we've almost fully recreated the basics of the creating view hierarchies in SwiftUI. It is a still long way to go as we delve into this wonderful library, but we have already tried out a lot of advanced techniques that are giving us amazing results. And this is just the beginning. That's all for today. Subscribe, press the like button and leave the feedback. This is Crafting Swift, and I'm Peter. Have a good day!